Okay, so hello everyone, this is Akshay here, and let us continue with today's problem of the day. And today's question name is get minimum square. The same question has been asked in LeetCode as well as 279 perfect squares. So let us switch back to our tab section and we'll see what are the important things given to us in order to solve this question. We've been given a positive integer n. We need to find the minimum number of perfect squares, that is square of an integer that sum up to n, right? And every positive integer can be expressed as a sum of square numbers. ठीक है, ये फालतू सा बात है. तो इनपुट एज ऑफ नाउ वी हैव लेट्स से 100. तो बहुत सारे तरीके हो सकते हैं दैट वी सम द स्क्वायर ऑफ 100 टाइम्स, राइट? तो 100 स्टेप्स लगेंगे उसमें. सो आउट ऑफ दिस सेवरल पॉसिबिलिटीज वी नीड टू रिटर्न द मिनिमम नंबर ऑफ perfect squares required to make up that sum. So here the minimum would be कि 100 एक perfect square number ही हो, like 10. Similarly for 6 you can see 2 square plus 1 square plus 1 square. So how many squares which we have used? 3 thrice, right? So 3 is the answer. Similar is the question on the LeetCode. Now how are we gonna solve this question यार? अगर देखो इसके दो तरीके multiple approaches होंगे. Let us see one by one, right? तो one observation you can see here is that all the numbers, if you solve the question of prime numbers, if not, do check it out, DSA 360, that is in the description. So the first observation is that if sum of all the square numbers, right, to make that particular sum would be in the range from 1 to, let's say, x less than equals to under root of n, right? Why is it so? Let's say for 100, the square root of 100 would be 10, right? And 10 square 100, तो ये हो गया. Let us take some another example. Let's say 43, right? So under root of 43, I know it would be a floating number, but let us say that we take the integer value of it, right? So it would be something 0.6 non-fractional value, but taking the integer point, it would be 6, right? And 6 are 36. So 36 plus some number which will give you 43, right? So definitely ये जो number है here, if you form with the use some numbers that is some and you square it to form this particular number, that would definitely be less than 6, right? That would lie in the range of 1 less than equals to x till less than equals to under root of n, right? So that was one basic point, and that will actually solve the question, right? So agar aap, if you have seen this question for the first time, maybe you went through the greedy approach, right? What did you do? That for this 43, what you maybe have formed this sequence, that's 6 square plus the rest of the elements are 7, right? So for 7 you made up like this, let's say 2 square, that would be give you 4, and then 1 square plus 1 square plus 1 square, right? So this is one of the possibility, but the number of squares which we have used is 5, right? There would be another possibility of using let's say 5 square and 3 square plus 3 square, which will give you 25 plus 9 again 43, right? But the number of squares which we have used here is 3, right? So obviously the greedy approach will not work. We can see it here. So that makes us to jump to our next topic of exploring all the possibilities and taking the minimum via recursion, right? So as I said, according to observation number 1, we need a for loop, right, going from I equals to 1 till I less than equals to root n. This statement can also be written as I star I less than equals to n, right? That remains same, squaring on the both side LHS and RHS, right? And what we need to recur for, we need to recur for, let's say, function, right? Now you have taken, let's say in this 43, right, you have taken some square, let's say of x square, right? I'm saying that this would be x square would be a part, and sum plus y square, that would be summation, will give us 43, right? So once you have taken this x square, then definitely the current number will decrease by that particular square. So for the next recursive call, when you call it, you will call it for my current number minus the square of the number which you have taken, right? And that's it. And we need to return the minimum of it, right? So whenever you have used the square, I will use one step, right? So 1 plus this function of this thing, and I need to return the minimum, right? So let's say we'll track this in an answer, and we would say that answer is nothing but the minimum of this thing, right? This would be a recursive code here, but what would be the time complexity for this one? I would say the time complexity would be k star n, right? And what k here is nothing but, it would be nothing but square root of n, right? And every, because there is a for loop here, right? And for every I you are going for maybe for at max n times, because using a loop of 1 square plus 1 square plus 1 square, right? So square root of n power n, right? So this is a very bad time complexity and definitely you'll get a TLE, but let's code this solution and then we'll move on with the memoization and tabulation. So let us quickly jump back to our computer screen and let's start coding it. So it is always a good practice to make another function. So I'm making one. So I'm saying int function and I'm gonna pass this integer and integer. Now the base case for running the recursion, we must have a base case so that we do not go into this infinite recursion, or let's say a loop. So if the number is 0, then definitely we do not require any squares and we would say the answer is 0, right? And let's just complete the code now. So we need to track the minimum, right? So I'm gonna declare my answer as maximum value, right? And we're gonna have a for loop that would be going from int I is equals to 1 till I star I less than equals to n and I plus plus, right? And I'm gonna say that my answer is nothing but math.minimum of 1 plus the same function, but this time my n would reduce by I square, and I'm gonna compare it with answer, right? So I think this is correct parenthesis I am making. That is good. And at last I'll just say return my answer, right? And I'm gonna call this function here, so return function of n, right? So let us submit this code. Okay, so there is something I have written capital N, but it should be small, right? So let's submit the code again. Now you would see that's a very bad time complexity and only 10 cases have passed, right? So again, as I said, converting from recursion to memoization is very simple. So what we need to do, 3 steps. So we will make, or let me give you some intuition behind it again. Coming back to our tab screen, right? So let us say why are we using optimization, that is memoization and tabulation, right? So let us say the n was 6, and then you make a recursive call for 1 star 1, which reduces the sum to 5. Then you again made a call for 1 star 1, reduces the sum to 4, and then 3, and then 2, and then finally it goes to 1, and then it goes to 0, right? Now what you will see that the next recursive call here is for 1 till less than square root of that number, right? So here nothing would happen. Similarly here nothing would happen because 2 star 2 will give you 4, right? So the next recursive call would be for here, that is 2 star 2 4, and 4 minus 4 will give you 0, right? And you would see that there are some now the recursive sub problems. So for 0 already we have a base case. Let us do some more diagram to understand where are that actual sub problems just solving for. So for this 6, for loop starts from I equals to 1 till square root of 6, taking the integer value, that would be nothing but 2.nnf, and taking the integer value, it would be 2. So another recursive call will be done for 2 square, and 6 minus 4 will give you 2, right? Clearly I can see now this is one of my sub problems which is getting repeated, right? So 3 steps. One step is to make a DP array and store this particular state whenever you're calling the recursion. From the next time when you call a recursion, use that particular stored state to get the value of 1, right? Coming back to our tab screen, and I'm gonna make a DP array and I'm gonna initialize it here. So DP is nothing but new int of n plus 1, right? And here we are calling the recursion, right? So before calling the recursion itself, I need to check that if that particular state is present. But before that, the first step is that you initialize the DP array and then you fill it with some number which could not be a possible answer in any of the scenarios of this recursion. So negative integer would never be an answer. So we fill it and we check it here before calling the recursion itself, that you are calling the recursion for which number, for n, right? So if it is not equals to -1, then definitely you have updated that particular state with some values and you just return that value, and we do not need to go for all these further steps, right? But for once it would be एक बार तो calculate करना ही होगा, right? So once this recursion is completed, right, store that particular state. So where are you gonna store it? In the DP array with what value? Answer. And you're gonna return answer or DP of anything is fine, right? let's now hit the submit button. And what would be the time and space for this one now? The time and space for this one would be n into square root of n. So let me switch back to my tab screen again. So as of now, we saw recursion, we saw memorization, and here the recursion time constant was k star n, and recursive stack space was O of n, right? And memoization, what would be the time? N into root n, and n of n O of n, because we used DPR, right? So why n into root n here? Because each n is solved once and each states loop over root n times, right? So there is some syntactical error here. Let me see it. Okay, so there was the error. We have already initialized the DP array, right? And here we are assigning, so no need of square brackets again at the LHS side. So let us wait for this code to compile. Great. Now let us look at the final approach, that is the tabulation one, and how is that working. Okay, so let us start with the tabulation one. So tabulation approach is also known as bottom up. So that means we start from the lowest I value and we go to the topmost, that is the n. So we start from 0 and we go to n, and whereas the memoization is the vice versa, we go from top down, we start from n and we go to 0, right? So the things which we'll be needing here is, again, we'll be needing a DP array, and this time we do not need this function. Our recursive function is not needed because that's a purely iterative approach. So we're gonna declare the DP inside the function itself, and let me zoom in a bit, and we're gonna fill this. Filling is not required now. And what else? We're gonna maybe fill the value with max, because we need to track the minimum, right? At DP of I, we need to track the minimum, right? So I'm gonna fill it with the max. Yes. Great. And again, our base case for I equals to 0, that is for sum equals to 0, we do not need any number of squares. So DP of 0 is equals to 0, and we're gonna have a for loop now. So how are we gonna fill the table bottom up, right? So we compute the answers for all the values, that is from I to n. We need to basically fill the DP array first of all, right? So this for loop will be would be required in our case. So now after this, our actual logic starts ki how are we actually going to fill the array with this particular calls, right? तो आपको ये तो समझ में आ ही गया होगा कि we are actually trying every square which is for less than equals to y, right? So that means we need another for loop that will go from j equals to 1 to j star j less than equals to I and j plus plus, right? Because j star j here is nothing but perfect square, and we check all the perfect square for less than equals to I, right? So what I'm saying is that, coming back to my tab screen, what I'm saying is ki let's say you have I equals to 12, right? And what you will do is ki for j would be starting from 1, which will point to 1, and again j will be starting to 2, which would be the square would be again 4, and j equals to 3, square would be 9, and j is equals to 4, the square would be 16, and since 16 is greater than our 12, so we will stop it here, right? So the square checked would be 1, 4, 9 for this particular for I is equals to 12 in this case, right? I hope that makes sense. And step 6 would be the straight transition, that is let me write it down for you now. So it would be for loop of int j is equals to I till j star j less than equals to I and j plus plus, and we're gonna say that dp of I is nothing but dp of, we're gonna use the same statement, right? So let me use the same statement, and we're gonna then just rephrase it, right? So dp of I, we're gonna compare it with the dp of I, obviously, and we're gonna replace this function with 1 would be there, but it would be nothing but dp of let me write it again for you. So it would be nothing but dp of I minus j star j, right? Hope that makes sense. And that would be it for this one. And we're gonna return not the function of n, but our actual answer would be stored in dp of n, right? So Writing the recursion part, maybe it's a complex part, but after you're done with that, it is easier to convert your code in memoization and tabulation once you are well versed with the basic or the standard question which is mentioned in the DSA 360, right? So do check it out. Now let us submit the code and let us have a quick recap on what approaches which we saw and what were the time complexity related to it. So what is there? Okay, I think my screen was not present, but I hope you were able to make sense out of it. Yep, I got the error, so we do not have to start from 0, right? So it would be starting from 1 because dp of 0 is 0. We have already filled that, right? Let us hit the submit button now and we will have a quick recap. Great, so that works. And what else? I can show you one more dry run as well, just to be so that you can be familiar. Yeah, I think I have explained enough and mera question ho gaya. So do a dry run yourself for this approach if you are still not able to clear it. And let us discuss the time complexity now. तो हमने recursion देखा for stands for k star n OFN, and हमने memoization देखा, and then we saw tabulation. So again the complexity is n star n and OFN, right? So which one is preferred more? So tabulation, the iterative approach is always preferred because it's faster, right? Even though the time complexities are same, but still we say that tabulation is better because it's an iterative approach, right? So what else? One of the main reason being that in the stack, in the memoization, you are using a DP array plus your stack space as well. That is also a factor here. So that's the reason. Now, there is one more approach which is something called Lagrange's theorem, right? But I'm not gonna explain it. That would be your homework if you want to explore more. The reason I'm not gonna explain it because I don't think this would be asked in the interview. If they have given you this question, then these methods are sufficient enough to clear that interview, right? And let us end this video on this good note, and we'll meet again tomorrow. Till then, keep learning, keep doing, goodbye, and take care.